Q4873-2. If a helicopter is in an unusual flight attitude and the attitude indicator has exceeded its limits, which instruments should be relied on to determine pitch attitude before starting recovery? A. Turn indicator and VSI. B. Airspeed, VSI and altimeter. C. VSI and airspeed to detect approaching versus 1 or VMO. The correct answer is B. When the attitude indicator fails, the pilot must rely on other instruments to determine the helicopter's attitude. The airspeed indicator, VSI, and altimeter can be used to determine the helicopter's pitch attitude. The airspeed indicator will show the helicopter's speed relative to the air. If the helicopter is in a nose-up attitude, the airspeed will be low. If the helicopter is in a nose-down attitude, the airspeed will be high. The VSI will show the helicopter's rate of climb or descent. If the helicopter is in a climb, the VSI will show a positive rate of climb. If the helicopter is in a descent, the VSI will show a negative rate of descent. The altimeter will show the helicopter's altitude. If the helicopter is in a nose-up attitude, the altitude will decrease. If the helicopter is in a nose-down attitude, the altitude will increase. By combining the information from the airspeed indicator, VSI, and altimeter, the pilot can determine the helicopter's pitch attitude and make the necessary adjustments to recover from the unusual attitude. The turn indicator and VSI are not as helpful in determining the helicopter's pitch attitude. The turn indicator will show the helicopter's rate of turn, but it will not show the helicopter's pitch attitude. The VSI will show the helicopter's rate of climb or descent, but it will not show the helicopter's pitch attitude. The airspeed, VSI, and altimeter are the most helpful instruments in determining the helicopter's pitch attitude when the attitude indicator fails. Q4875-2, which is the correct sequence for recovery from a spiraling, nose-low, increasing airspeed, unusual flight attitude? A. Increase pitch attitude, reduce power, and level wings. B. Correct the bank attitude, raise the nose to a level attitude and reduce power. C. Reduce power, raise the nose to level attitude, and correct the bank attitude. The correct answer is B. To bounce back from a typical attitude, fix bank and pitch attitude, and make any required power adjustments. 4976. When a pilot believes advanced avionics enable operations closer to personal or environmental limits? A. Greater utilization of the aircraft is achieved. B. Risk is increased. C. Risk is decreased. The correct answer is B. Advanced avionics can provide pilots with a number of benefits, such as improved navigation, weather forecasting, and collision avoidance. However, these benefits can also lead to pilots believing that they can operate their aircraft closer to personal or environmental limits. This can increase the risk of an accident. For example, a pilot with advanced avionics may be tempted to fly in IMC, instrument meteorological conditions, because they believe that the avionics will allow them to safely navigate. However, IMC can be very dangerous, and even the best avionics cannot always prevent an accident. Another example is a pilot who believes that they can fly their aircraft closer to the ground because they have advanced avionics that can help them avoid obstacles. However, even with advanced avionics, it is still possible to hit an obstacle, especially if the pilot is not paying attention. In general, advanced avionics should be used to increase safety, not to increase risk. Pilots should always be aware of their personal and environmental limits, and they should never operate their aircraft beyond those limits, even if they have advanced avionics. Here are some tips for using advanced avionics safely. Always be aware of your personal and environmental limits. Do not rely on advanced avionics to the exclusion of other safety measures. Use advanced avionics to supplement your own judgment, not to replace it. Get proper training on how to use advanced avionics. Keep your avionics up to date. By following these tips, you can help to ensure that you use advanced avionics safely and responsibly. 4977. Automation in aircraft has proven? A. to present new hazards in its limitations. B. That automation is basically flawless. C. Effective in preventing accidents. The correct answer is A. Automation in aircraft has proven to be a valuable tool for pilots, but it has also introduced new hazards. One of the biggest dangers of automation is that it can lead to pilots becoming complacent. When pilots rely too heavily on automation, they may not be as vigilant in monitoring the aircraft's systems and surroundings. This can lead to accidents if the automation fails or if the pilot is not prepared to take over manual control of the aircraft. Another danger of automation is that it can be difficult to override. If the automation is malfunctioning or if the pilot makes a mistake, it can be difficult to disengage the automation and take over manual control. This can lead to accidents if the pilot is not able to regain control of the aircraft in time. Despite the dangers, automation is still a valuable tool for pilots. It can help to reduce pilot workload and improve safety. However, it is important for pilots to be aware of the limitations of automation and to be prepared to take over manual control of the aircraft if necessary. For Q4977-1, an aircraft which is equipped with an electronic flight display, EFD can A. Compensate for an airman's lack of skill or knowledge. B. Offer new capabilities and simplify the basic flying task. C. Improve flight awareness by allowing the pilot to simply watch for alerts. The correct answer is B. An electronic flight display, EFD, is a digital display that replaces the traditional analog instruments in an aircraft cockpit. EFDs offer a number of advantages over analog instruments, including increased situational awareness. EFDs can display more information than analog instruments, and they can display it in a more intuitive way. This can help pilots to make better decisions in a flight emergency. Reduced workload. EFDs can automate some of the tasks that pilots would normally have to do manually, such as calculating fuel burn and navigation. This can free up pilots to focus on other tasks, such as flying the aircraft. Improved safety. EFDs can help to prevent accidents by providing pilots with more information and by reducing workload. While EFDs cannot compensate for an airman's lack of skill or knowledge, they can offer new capabilities and simplify the basic flying task. This can lead to improved safety and efficiency in flight operations. Here are some of the specific capabilities that EFDs can offer. Synthetic vision. Synthetic vision is a technology that creates a three-dimensional image of the surrounding terrain on the EFD display. This can help pilots to see in low visibility conditions, such as fog or rain. Enhanced weather radar. EFDs can display weather radar information in a more intuitive way than analog radar displays. This can help pilots to avoid hazardous weather conditions. Traffic information. EFDs can display traffic information from ground-based radar systems. This can help pilots to avoid collisions with other aircraft. Automatic flight control. EFDs can be used to automate some of the tasks that pilots would normally have to do manually, such as flying the aircraft on autopilot. This can free up pilots to focus on other tasks, such as monitoring the aircraft's systems and surroundings. Overall, EFDs offer a number of advantages over analog instruments. They can improve situational awareness, reduce workload, and improve safety. As a result, EFDs are becoming increasingly common in aircraft cockpits.